Okay, hello, welcome. Okay, so this is a tutorial on the PWM versus MPPT solar charger simulator educational kit. Okay, so if you want to get this poster, there are two posters actually. Okay, for now there are two posters. So if you want to get it, you just flip it at the back. You can get the poster and guide. Okay, I will put everything here. So we start with the conventional educational kit, which is this one. Okay, so normally we buy this and connect with PV battery and the load. Usually the load is the lamp or fan. Okay, so this kind of educational kit is have a lot of limitation. Okay, so usually we have problem conducting the academic service learning in the school because of the limitation. Okay, so this is the limitation. You can read about it later. But to overcome this, we create this one, a PWM versus MPPT solar charger controller educational kit. So basically, it's overcome most of the limitation. Okay, so maybe I will discuss a little bit. So you can see here, this one requires sunlight, but the problem is sometimes it's raining or the activity is done indoor, okay, due to the hot weather. So basically we cannot conduct this. Okay, and usually we use PWM because MPPT is expensive. Okay, so another thing is change of battery cannot be observed because usually we buy a standard battery which is around 10 mAh or 20 mAh, and the change cannot be observed because the battery is quite large, so it's not good for learning. Okay, and if you use MPPT, you also cannot observe it because MPPT actually is quite fast, less than 1 second. Okay, and next, difficult to observe the battery full and depletion. So usually large battery, to make it full you have to charge a long time, and to deplete it you have to wait a long time also, so you cannot observe the algorithm when the battery is full or depleted. And another thing is it needs multiple sensor because this is don't have any sensor normally, so you need to have everything you have. Okay, voltage, current, SOC, so basically around 6 sensor and of course 10 display to look all these parameters. So that is the limitation of this educational kit. And of course the sensor and display is quite high in cost, and also you have a safety issue because if you don't be careful you can short the battery and can cause fire. And of course this one is quite heavy. The battery usually around 5 kilo if not mistaken. The PV panel is 10 kilo. Okay, the load and everything is quite heavy, depending on the rating, but usually around, if not mistaken, around 10 kilo. Okay, for this one it's quite difficult to carry and take a lot of space. If you bring it in the car for the academic service learning, for example, it's quite difficult. Okay, so that is the limitation. So basically this educational kit provide a relief for all of these limitation. So this one, so basically you don't need sunlight because you control it using the potentiometer. Okay, you can switch either PWM or MPPT. So for this case, okay, if you go to the market, usually this is the important thing because we want to learn PWM and MPPT solar charger controller. Basically when you go to the market, there can be either PWM or MPPT, and MPPT usually around 3 to 4 times more expensive compared to the PWM. So I will show you the difference with the educational kit. Okay, so MPPT is set to be slower. This is just for educational. You can see how it tried to find the maximum power. So you can see it before this is only 1 second, less than 1 second. But because of this, I slow it down to around 20 seconds. So change of battery can be observed because I can set this battery into a very small. So you basically can charge the battery around probably around 1 minute. Okay, so you can see the changes, and you can see the battery full and deplete state condition. Okay, so basically because of the battery is very small, it can observe it quickly. And of course because this is simulation, okay, simulator, So you don't need to have a sensor, and of course you can build in a display because you don't need sensor, you don't need separating. Okay, so this can be only be show in one display, so it can easily look. Okay, you can observe it easily, and of course low in cost, and there is no safety issue because there is no battery to short circuit, and it is light and small. You can see here, this is small. Okay, so that is the first thing. Okay, and of course don't forget the disclaimer at the bottom. You can see here, for practical, MPPT needs to be fast and battery needs to be large, but for this case we flip it because it's for learning purpose, but in reality you need to be, MPPT needs to be fast and battery needs to be large. Okay, for fully charged and depleted, okay, method for fully charged and depleted depend on manufacturer. So this is one of the method, but sometimes other company use a different method, so this is just one of the method used. Okay, so that is the disclaimer. So this is the how the system work. Okay, so basically you have two mode. One is for MPPT, one is for solar charger. So we better look at MPPT first. You can see here, this is PWM. We look at PWM first because it's much more simple. Okay, PWM solar charger, you can see here you have two switch. This is the battery deplete controller. Basically when the battery is depleted, it disconnect the load. So that is another one. Okay, and this one is PWM. Okay, so you can see here the PWM. Okay, so the PWM is here. Okay, this one. Okay, so this PWM is controlled at the PV side. So this is the this is how the PWM work. So basically it's like connecting the PV directly to the battery. Basically switch on and off. Basically when the battery is full, disconnect, and when the battery is when the battery needs to be charged, is connect. Okay, so what happen when you connect PV to the battery? So you can see here, the green is the current voltage characteristic of the PV. It's not linear. That is the problem with the PV. The characteristic is not linear. So basically what happened is the current is constant. Okay, you can see here, this is the current. After a certain point, when you increase your load, suddenly the current stop to increase and start to decrease. Sorry, not start to increase, start to decrease. Okay, the current start to decrease, and as you increase the load, it become lower and lower. And you can see here, this is the current. So you can see here, the when you increase the load, you increase the voltage, and the power also increase. This is the power against voltage characteristic of the PV. So you can see here, it increase, and this is the maximum. Basically, if you want to operate the PV properly, you have to operate at this location. So basically you have to operate at this location because this is the maximum power you can observe. Okay, but when you use PWM, the problem is it is not short circuit, it is connected directly to the battery. It's like parallel to the battery. You can see here. As the result, the PWM operates here. So you can see here, it's operate here because of the VBAT equals to VPV. Total voltage equals to battery voltage. As a result, the maximum power cannot be achieved. So basically, power of the PV is less than the power of the maximum point. This is power of maximum point. So that is the PWM operation. Basically, the voltage of the battery and the PV will be the same. So how about the MPPT? So MPPT, of course, it is much more complicated algorithm, and it require a power converter. It's usually buck converter, and sometimes different company use different converter. So basically, the converter, you need to add converter. That's why it become more expensive compared to this. This one is just normally a switch or thyristor, if not mistaken. But for the MPPT, you need a full power converter. Okay, So as a result, it is become more expensive. The other one is almost similar, but this one is also expensive. Okay, much more expensive. So how MPPT work? So basically the algorithm usually start at V battery. Normally start at V battery, and it will start to search for the maximum power. Okay, it will try to track, maybe start from here, it try to track and get the MP, maximum power. So basically voltage of the PV is equals to voltage of the MP, the maximum power. So basically voltage of the battery, for example, this one is 24 volt, for example, but the voltage here is more than that, usually around 38 or 39, depending on the VMP. Okay, this one you can get from the manufacturer. Okay, but for this case, the voltage will be the same. That's why if you use MPPT, it's much more efficient, usually around 90% efficiency. But if you use PWM, is around 70% efficiency. So depending on the manufacturer, but because of this characteristic, it be lower. So one is the interesting question I get before, why we just don't put this voltage here. Okay, for example, this is 40 for easy understanding. This is 40, VMP is 40 because of the PV is the VMP is 40. Why don't just we choose the VBAT equals to 40? So one of the limitation is because manufacturer usually don't provide a specific voltage that we want, usually 12, 24, 48, something like that. So you have to choose according to the manufacturer availability. Okay, so that is one problem. And if you set, for example, suddenly you get a 40 volt battery here. So if you set here, what happened is, let me show you a figure. Is not here. Okay, so you can see here, this is the another graph. Okay, so what is mean G is the irradiance. Okay, you can see here, this is low irradiance, low sun intensity. This is high sun intensity, G, irradiance. Okay, so what happened if you choose the VBAT equals to here? Okay, so when the irradiance is high, is good. Okay, it's not, you have no problem. But the problem is when the irradiance is low, you can see here, it will not achieve the maximum power. So maximum power is around here. Because you choose here, it will change. Basically, the VMP and PMP, VMP is changed according to irradiance. So different irradiance, different level. Okay, so that is why battery voltage, if you choose higher, it doesn't matter, because when the irradiance change, the VMP will change. So that is the limitation. Okay, another disclaimer here. Usually this kind of the controller usually don't use SOC. SOC is basically state of charge of the battery. If you look at your phone, there is a percentage of the battery that is basically the state of charge, SOC. But in this kind of system, normally we will use the voltage, okay, not the SOC. So battery, usually when the battery is depleted, voltage decrease a lot. Okay, not a lot. Usually if 12 volt, it become 9 volt if depleted. But for full, it can increase up to 13. Okay, it's not 13, 14. So basically, instead of using SOC, they use a voltage. But for the learning purpose, we use SOC for easier understanding. Okay, that's it. I hope this one is good enough for understanding the educational kit. So thank you and goodbye.